So now we're going to be looking at some past questions to see how to apply some of the concepts we've learned as regards to the applications of differentiation. So let's get started. In the first question, we are told to find the slope of the curve y is equals to 2x squared plus 5x minus 3 at 1, 4. So this is the coordinate where they want us to find the slope. So when I was explaining, I told you that to find the slope of a curve, we have to find the slope or the gradient function, and to do that, we just differentiate the expression of the curve. So when I differentiate this function, I have what? I have dy over dx to be equals to, when I differentiate 2x squared, I bring this 2 down, so I have 2 times 2, which gives me 4x, and I reduce the power by 1, 2 minus 1, which gives me 1. Then this becomes, differential of 5x becomes 5 because I have just x, so I take only the coefficients. And minus 3, which is a constant, becomes 0. So I have 4x plus 5, which gives me the gradient function. Now we are told where they want us, the position in which they want us to find the slope. So I told the coordinates to be what? 1, 4. So we know that will mean that our x value is 1 and our y value is 4. So I can substitute my x value into this expression here, since I have it in terms of x. So dy over dx becomes 4, and my x is 1 plus 5, and that becomes 4 plus 5, and that gives me 9. So dy over dx, which is the same thing as the slope, is equals to 9 in this case, and that makes D the correct option. In the next question, we are told that if s is equals to this, we should find ds over dt when t is equals to 4 over 5 seconds. So the same logic applies here. So what do we have to do? We have to differentiate this expression over here. And how do we differentiate that? You can choose to expand this, then you differentiate each of the terms using the principle of the differentiation of algebraic expressions. What I'm going to do now is to apply the product rule. So in the product rule, I equate this term over here to u and this term over here to v. So I have my u to be equals to 2 plus 3t. So my du over dt becomes what? 2 becomes 0, 3t becomes 3. And I say my v to be equals to what? 5t minus 4. So my dv over dt becomes what? Becomes 5t becomes 5 and 4 becomes 0. So if you remember our product rule, d over dt of uv is same thing as having what? U dv over dt plus v du over dt. So I can apply that. So that becomes, what is my u? 2 plus 3t. And what is my dv over dt? 5. Then plus, what is my v? 5t minus 4. And what is my du over dt? 3. So I can expand. 5 times 2 gives me 10. 3t times 5 gives me plus 15t. 5t times 3 gives me plus 15t. And minus 4 times 3 gives me minus 12. So when I collect like times, I have my ds now over dt to be equals to 5t plus 15t plus 15t gives me 30t, and 10 minus 12 gives me minus 2. So I'm told to find it ds over dt when t is equals to 4 over 5. So I can substitute the value of 4 over 5 into this expression. So my ds over dt equals to 30 into bracket 4 over 5, then minus 2. 5 here 1 and 5 in 30 is 6. 6 times 4 gives me 24. So I have 24 minus 2, and that is equals to 22. So the correct option here is C, which is 22 units per second. And the reason why it's units per second, you remember differential of distance s gives us the velocity, which is measured in length per second. So the correct option here is option C. So let's move on to the next question. And here we are told that the radius of a circle is increasing at the rate of 0.02 centimeter per second. Find the rate at which the area is increasing when the radius of a circle is 7 centimeter. So we've talked about how to solve questions that are similar to this. And what do? we apply the chain rule basically. So we are given the rate at which the radius is increasing. So we are told that the rate which gives us the r over the t, the rate at which the radius is changing with time, we are told to be equals to 0.02 centimeter per second. Now we are told to find the rate at which the area is increasing. So the a over the t, that is what we are trying to figure out when the radius of the cycle is what? 7 centimeter. Now what is the formula for calculating the area of a cycle? The area of a cycle is given as what? Pi r squared. So I can differentiate the area of a cycle with respect to the radius. So the a over the r becomes, when I differentiate pi r squared, I bring these two down to have 2 pi, then I have r raised to the power 2 minus 1, which gives me 1. So I have 2 pi r. So now if you remember from our chain rule, the a over the t can be written as the a over the r times the r over the t, because the r over the r cancels and I'm left with the a over the t. So that becomes my dA over the r is given as 2 pi r times my dA over the t is given as 0.02. So now dA over the t equals to what? 2. Value of pi will take to be 22 over 7. The radius we are told is equals to 7 centimeter, then times 0.02. 7 cancel 7. 2 times 22 is 44, and when you multiply 44 by 0.02, you get 0.88. That becomes unit of area, which is cm squared per second. So the rate at which the area is increasing, dA over the t, is 0.88, and that makes the correct option to this question option B. So now in this example, or in this question rather, we are told to find the value of x at the minimum point of the curve. So now we have a curve and we are told to find the value of x at the maximum point rather. So what do we do first? We try to find the turning points of this curve. And how do we do that? We differentiate this expression and we equate it to 0, because you know that at the turning point dy over dx is 0. So I write that out. At turning point dy over dx is equals to 0. So I'm giving that y is equals to x cubed plus x squared minus x plus 1. So I can easily find dy dx. So dy dx becomes 3 comes down, so I have 3x, and 3 minus 1 becomes 2. Then 2 comes down, so I have 2x, 2 minus 1 is 1. Then it becomes minus 1, and this becomes 0. So I can equate this down to 0, since I know that at the turning point dy dx is 0. So I can try to factorize this. When I multiply the first and the last term, I get minus 3x squared. So you ask yourself, what two numbers can I multiply together to get minus 3x squared? When I add them together, I get 2x. So obviously that becomes what two numbers? That becomes plus 3x and minus x. 3x minus x gives me 2x, while 3x times minus x gives minus 3x squared. So I can write this as what? 3x squared plus 3x minus x minus 1 is equals to 0. So 3x is common here. When I factorize, I'm left with x plus 1, and here minus 1 is common. I'm left with x plus 1. So what does that? So what do I have? So I have what? X plus 1 is equals to 0, or 3x minus 1 equals to 0. So in this case, x is equals to minus 1, and in this case, x is equals to 1 over 3. Now I have two values of x, and both of them are in the option. You can see minus 1 as D and 1 over 3 as A. Which one do you pick? Now the question told us to find the value of x at the maximum point. So what do we need? We need to figure out which of these two values of x represent the value of x at the maximum point. And to do that, you recall, we apply our test for finding the maximum point and minimum point. And you recall that what we just do is you differentiate again. So To find the maximum and minimum point, we find the squared y over dx squared. If it is less than 0, we know that it is what? It is a maximum point. And if it is greater than 0, we know it's a minimum point. So let's try to differentiate this function once again. So the squared y over the x squared will be equals to what? When I bring 2 down, I have 3 times 2, which gives me 6. Then x, 2 minus 1 gives me 1. Then plus 2x, when I differentiate 2x, I get 2. And minus 1 becomes 0. So the squared y over the x squared is equals to 6x plus 2. So let's test out our two values of x. So let's start with when x is equals to minus 1. So let's put that into here. And what do we get? I get my d squared y over dx squared to be equals to what? 6 into bracket minus 1 plus 2. Right? And what does that become? That becomes, have I made a mistake somewhere? No. Okay, plus 2. So that becomes what? That becomes minus 6 plus 2. And that gives me what? Minus 4. So now that I'm having a number that is negative, I know that this is my maximum point. So now let's write out the other values. So when x is equals to what? 1 over 3. So what does my d squared y over dx squared becomes? It becomes what? 6 into bracket 1 over 3 plus 2, which becomes 2 plus 2, and that gives me what? 4. So as you can see, in this second example, in this second condition, when x is 1 over 3, my d squared y over dx squared is greater than 0, which is 4. So that means the value of x at 1 over 3 represents my minimum value, and when x is minus 1, it represents my maximum value. So the option to select out of these two is the value for which x is minus 1. So that makes the correct option to this question option D. So that is D. So to recap, what we did was to try to find the values of x by using the condition that our turning point dy dx is 0. And we got two values of x, but we could not tell which was maximum and which was the minimum point. So we now applied our test by finding the second derivative. So if you recall from our test, if the second derivative is less than 0, we know that it's our maximum point. If it is greater than 0, we know that it is our minimum point. And if it is equal to 0, we know it's our point of inflection. So when we differentiated it the second time, we got 6x plus 2. So we tried both values of x. So when x was minus 1, we got a negative value which is less than 0, which tells us that that is the maximum point. And when x was equal to minus 3, we got a positive value 4, which is greater than 0, which tells us that this is the minimum value. So that is how we knew that the option to select was the one in which x is equal to minus 1, because that is the value of x at the maximum point, which makes the correct option option D. So let's move on to the next question. And here we are told to find the value of f of x for which the function this has a minimum function. So now we are told to find this. So again, we know that when you have a maximum or a minimum point, dy dx is 0. And if you recall, f of x is the same thing as having just y is equals to this. So don't allow the notation to confuse you. So to solve this, I know that my f of x is equals to 2x cubed minus x squared minus 4x plus 4. So when I differentiate this with respect to x, so f prime of x, which is the same thing as differentiating this, equals to, when 3 comes, I have 2 times 3, which gives me 6x squared. When 2 comes, I have minus 2x, then this becomes minus 4. Then now that this will be equals to 0. So I can easily factorize this. So 6 times 4, we know it gives me minus 24x squared. So what two numbers can I multiply together to get minus 24x squared? But when I add or subtract, I get minus 2. That works out to be minus 6x and plus 4x. So when I replace it with minus 2x here, I have 6x squared minus 6x plus 4x minus 4 is equals to 0. So when I factorize, 6x is common and I'm left with what? X minus 1. And here plus 4 is common, into bracket x minus 1. That becomes x minus 1 is equals to 0, or 6x plus 4 is equals to 0. When you solve this, you have x is equals to minus 1, or x is equals to plus 1, or x is equals to minus 2 over 3 when you simplify this. So now you ask yourself, how am I going to know which of this value of x represents the minimum value? So again, we apply our test of the squared root over dx. So I want to find the squared root over dx squared. If it is greater than 0, which is positive, then we know we have our minimum value. So we'll try to differentiate this function once again. So that same time as writing f prime of x. And you should notice something by now. When you have 1 prime here, it means you differentiated it once. When you have 2 prime, it means you differentiated it twice. So this is another notation of differentiation. So f prime of x, which is something as the square root over dx squared in this case, will be equals to, I bring this 2 down here, so I have 6 times 2, which gives me 12x, and my 2 minus 1 gives me 1. Then I have minus 2x. Since I have only x, I take all of the coefficients, and that becomes just minus 2. So I apply my test now. So when x is equals to 1, what is my value here? So my f prime of x, which is that my second derivative, will be equals to 12 into bracket 1 minus 2. And that is what? 12 minus 2, and that is equals to 10. So I can see this positive here, value here is positive and is greater than 0. So that means that what? When x is equals to 1, we have the minimum value, or we have the minimum function over here. So now you can try to solve it and put your value of x as minus 2 over 3 into this expression for the square root over dx squared. And if you do that correctly, you are going to get it to be equals to minus 10. And that means when x is equals to minus 2 over 3, you have the maximum value. So now we know that this is the option to select, because it's at this function, or at this value of x, that will have the minimum value. But the question to at minimum x is equals to 1. But the question does not ask us to find the value of x. It asks us to find the value of f of x at the minimum point. So now I know that my f of x is given by this expression as well, 2 in the bracket x cubed minus x squared minus 4x plus 4. And if you remember our discussion on function, explain that f of x just represents that for any value of x, you just replace it with everywhere you see x over here. So this is same thing as having f of 1, since my x value is 1, and that becomes 2 in the bracket x here becomes 1 cubed minus 1 squared minus 4 into bracket 1 plus 4, and that becomes 1 cubed is 1 times 2, 2, 1 squared is 1, 4 times 1 is 4, then plus 4. So what do you have? You have this cancels out this. I have 2 minus 1, and 2 minus 1 equals to 1. So the value of f of x when x is equals to 1 is also equals to 1. So the correct option to this question is option B. So it's just a coincidence here that the value of x is the same thing as the value of f of x. So you should always be careful and try to solve it if the question specifically asks for you to find the value of f of x or the value of y. So let's move on to the last question that I shall be considering. So here we are told to find the minimum value of y is equals to x squared minus 2x minus 3. So again, I know that at the turning point, the y over the x must be equals to 0. So I can differentiate this expression. So I have the y over the x to be equals to x squared becomes 2x, and minus 2x becomes minus 2. So I equate it to 0. So what does that become? I have 2x is equals to 2, and when I divide both sides by 2, I have my value of x to be equals to 1. So at the minimum point, I get x equals to 1, and we do not need to test in this case because we have only one value of x, and since the question tells us that is at the minimum point, we know that this definitely represents the minimum value of x. So now to find the minimum value of y, we just substitute it into this expression. So my y we told is equals to x squared minus 2x minus 3. So when x is equals to 1 now, and we have found x to be 1 at the minimum point, my y value becomes 1 squared minus 2 into bracket 1 minus 3, and that becomes 1 minus 2 minus 3, which is equals to minus 4. So at minimum point, x is equals to 1 and y is equals to minus 4. So now the question asks us to find the minimum value of y, and did not specifically ask us to find either x or y. So when you see a question like this, I would suggest that you just stick to choosing the option that has to do with y, because I'll read this normally as find the minimum value of y is equals to, so I want to find the value of the function, which is the value of y. So rather than select C, which is 1, I will rather select y to be equals to minus 4, which is option A. But for most questions I'm going to encounter, it's going to be specifically stated if you should give the value of x or y, or if you should give the values of x and y. But when it is not stated, like in this example, I will just suggest that you give the value of y as the answer. So that pretty much sums up our discussion on the applications of differentiation. So what I want to do now is try to go through your past question and look for questions that are related to applications. Also in the exercises that we shall be giving you, there are some questions that have to do with the applications that you should try to see if you can figure them out. And if you have any difficulty or encounter any difficulty, try to make use of the forum where you can interact with other students, and from time to time I will come online to see some of your questions and also try to see if I can be of assistance. So that will be all for now. Bye.